Welcome to Big Shine's webinar on power quality and its impact on LED lighting. Poor power quality can quietly damage LED systems and lead to costly issues. Today, we'll break down what you need to know to protect your installs and avoid unnecessary failures. Let's dive in. Power quality and its impact on LED lighting. Understanding power quality is crucial for anyone installing, specifying, or reselling LED lighting systems. Poor power quality can silently but steadily degrade performance, increase maintenance costs, and reduce the lifespan of LED products. Key reasons to care. LED sensitivity. Both LED chips and their drivers are delicate semiconductors. They are highly sensitive to voltage fluctuations and transient spikes. Electrostatic vulnerability. Even a minor static discharge can destroy unprotected semiconductor components. Surge protection limits. Most LED drivers have built-in surge protection devices, SPDs, but these have limitations both in how high a voltage they can suppress and how much energy, in joules, they can divert to ground. Cumulative damage. Repeated exposure to minor voltage spikes can gradually wear out SPDs. Over time, this leads to premature driver failure. Customer complaints. Momentary blinking or flickering caused by power quality issues is often misattributed to fixture defects. Economic impact. Power surges cost U.S. businesses an estimated $80 billion annually in downtime, equipment damage, and maintenance. Understanding key power quality terms. Voltage transients. Lightning induced. A lightning strike doesn't have to be direct to cause damage. A nearby strike can induce high voltage spikes through magnetic coupling. A strike 1 mile away may induce 70 volt. A strike just 160 yards away could generate spikes up to 10,000 volts. Origin. About 20% of power surges come from lightning. The other 80% come from internal sources, like large motors cycling on-off, HVAC systems, or industrial equipment. Impulsive transients, high voltage spikes. Short duration, high amplitude voltage spikes may last less than 1/2 an AC cycle, can result from lightning or equipment switching. A TVSS, transient voltage surge suppressor, can reduce this spike, but will clamp voltage at approximately 330 volts or more. Voltage surge, or swell. A rise in RMS voltage that lasts for several cycles, may persist for seconds, minutes, or even hours, opposite of a voltage sag. Common power quality problems. Define blackout. Complete loss of power for more than 2 cycles. Duration can range from a blink to hours. Voltage sag, power sag. A brief drop in voltage caused by starting large motors, utility grid switching, temporary overloads, lasts a few cycles to a few seconds. Brownout. Extended sag, lasting minutes to days, can stress power supplies and cause dimming or flicker in LED systems. Switching transient. Fast, high voltage spike of very short duration, often caused by power factor correction capacitors switching on and off, can damage both end-use equipment and protected devices like circuit breakers. Harmonic distortion. Nonlinear loads like VFDs, rectifiers, and SMPS in electronics distort the AC sine wave, common in energy-efficient HVAC systems. Problems include equipment synchronization failures, overheating in equipment and transformers. Frequency variation, deviation from the nominal 50 Hz or 60 Hz frequency. Though rare in regions with stable power grids, fluctuations can affect equipment performance. Normal mode noise. High frequency noise between line and neutral caused by radio frequency interference, electromagnetic interference. Typical sources: fluorescent lights, computers, variable speed drives, wireless devices. Common mode noise: noise between neutral and ground or line and ground. Affects digital equipment, leading to shortened component life, data communication errors, erratic behavior in sensitive electronics. Sources of electrical noise: external, storms, lightning, utility switching. Internal, fluorescent fixtures, high frequency noise. Motors, fans, pumps, transient noise. Switch mode power supplies in computers, chargers, etc. Takeaway for installers and contractors: power quality issues often masquerade as product failures. Proper diagnosis protects your reputation and prevents callbacks. Always evaluate the power environment where LED systems will be installed. Use properly rated surge protection devices tailored to the environment. Know the energy level, joules, and clamping voltage. Consider whole building surge protection when appropriate. Consider power analyzers or monitoring tools for large or sensitive installations. Power quality is invisible, but its effects are not. With the right knowledge and protection, you can extend the life of LED systems, reduce downtime, and avoid costly misdiagnosis. Thanks for joining. See you next time.